Hello, this is FlippedHarber for Physics. In this video we'll be going over the practice problems on page 74, numbers 42 through 46. Number 42 asks, a construction worker accidentally drops a brick from a high scaffolding. What was the velocity of the brick after 4 seconds, and how far does the brick fall during this time? Now, to answer what's the velocity of the brick after 4 seconds, one thing we need to realize is that when they tell us that an object drops, they're actually giving us some information about that. They're telling us that VI equals 0 meters per second. Whenever you see the word drop, you need to think, okay, that velocity up there is 0. We need to know that the acceleration is negative 9.80, that is the acceleration from free fall on Earth, and they tell us that the time is 4 seconds. So the equation that I'm going to use is V final equals V initial plus AT. Plugging in everything that I know, I find out that the final velocity is negative 39.2 meters per second. Now that's one too many sig figs, so the answer I should actually report is a negative 39 meters per second. Is that negative important? Absolutely. I stuck with the convention that up is positive, and when they ask what's velocity, I need to make sure that I'm including something about direction. And the way I'm doing that is with that negative. Alright, let's move on to part B. How far does the brick fall during this time? Again, I know that my VI is 0, my acceleration is negative 9.80, and my time is 4 seconds. I'm going to use my displacement equation. Now you'll notice there's no DI in this equation. That's because I'm going to go ahead and let DI be 0. When the brick first drops, it hasn't fallen anywhere yet. So, plugging in my VI is 0, my acceleration is negative 9.80, and my time is 4 seconds, I get that my final displacement is negative 78.4 meters. Now, here's a bit of contention about this problem. When they ask how far, a lot of times they're asking distance instead of displacement, but they actually ask how far does the brick fall during this time. That kind of implies that negativeness to the displacement. So just to be safe, I'm going to say that it falls 78.4 meters. Then I'm taking care of whether it should be negative or not by using their own words. Okay. Number 43 says, suppose for the previous problem you choose your coordinate system so that the opposite direction is positive. So if we buck the system a little bit and say that down is positive instead of negative, what's that do to our calculations? Not a whole heck of a lot. I've already done the math to find the final velocity. I just dropped that negative. The final velocity is 39.2 meters per second. And when I do my calculation for the final displacement, again, that negative just goes away. So don't redo work if you don't have to. Alright, let's move on to number 44. A student drops a ball, there's that word again, drops a ball from a window 3.5 meters above the sidewalk. How fast is it moving when it hits the sidewalk? Alright, now, I know I'm going to use 0 for VI. We've already talked about that. But look at my displacement. Why a negative 3.5 meters? Well, by letting my D final be negative 3.5 meters, that means that my D initial is at the window, and the sidewalk is below the window, so I use a negative 3.5. Now, what if you don't use that negative? We'll talk about that in a second. What's conspicuously missing from the information is that time variable. Now, could I find time? Yeah, I could, but it's too much work when I've got this really great equation where VF squared equals VI squared plus 2AD. No time at all. So let's just go ahead, take the square root to get rid of that square on the VF, and plug in my numbers. Now right here is where whether you have that negative on the 3.5 is a big important deal. If you don't have that negative on there and you try to take this square root in your calculator, it's going to get sick, it's not going to feel good because you're trying to take an imaginary number. Some calculators won't even do it, and some calculators will spit it out in a really odd way. So if you get some error from your calculator that it's a non-real number, check and make sure that everything that should be negative is negative and everything that shouldn't be negative isn't. By the way, our final velocity in proper sig figs is 8.3 meters per second. Number 45 says a tennis ball is thrown straight up with an initial speed of 22.5 meters per second. It is caught at the same distance above the ground. So this tennis ball goes up, comes back down, and is caught at exactly the same height. Question A, how high does the ball rise? So how far does it go up while it's traveling? And how long does the ball remain in the air? Now that second question, you got to make sure you're answering the right question. We'll talk about that. So our VI is 22.5. I'm going to take my VF for part A to be 0 because I know that when that tennis ball reaches the absolute top of its motion, it stops just for an instant. Now that's really handy when solving problems like this. I'm going to use my acceleration is a negative 9.80. And again, since I don't have time given, I'm going to use that VF squared equals VI squared plus 2AD. Solving for displacement, I have VF squared minus VI squared all over 2 times A. I plug in everything that I know, and I find out that this tennis ball goes 25.8 meters up in the air. So that would be above the height that it was thrown from. So if it was thrown from, let's say a meter high, that's 25.8 meters above that meter high height. Now, part B, how long does the ball remain in the air? Now, you got to make sure you're answering the right question here. The question is, how long does it take for the tennis ball to go all the way up and all the way back down? Not how long does it take to go up to that maximum height. So the trick here, it's not really a trick, but the concept that you have to get here in order to answer this question easily is when an object lands or is caught at the same height that it was thrown up from, that V final is exactly a negative VI. So I know that my final velocity is negative 22.5 meters per second. It's this whole symmetry of free fall. Plug into my basic acceleration equation, but I solved it for time. I get 4.59 seconds. 3 sig figs, I'm all done. Let's take a look at number 46. You decide to flip a coin to determine whether to do your physics or English homework first. Do them both. The coin is flipped straight up. If the coin reaches a high point of 0.25 meters above where you released it, what was the initial speed? So we're looking for VI there. Part B, if you catch it at the same height as you released it, how much time did it spend in the air? So again, how much time to go all the way up and all the way down? That's important. Make sure you're finding the total time. So for part A, we know that DF is 0.25 meters. We know that V final is 0 meters per second. That's why it's at the top of its motion, because it stopped for an instant. We're going to use this equation that doesn't have time, and we find out that its initial velocity was 2.2 meters per second. I forgot my per second there. Oh well. We'll move on with it. Number 46, B says if you catch it at the same height as you released it, how much time did it spend in the air? Now, I'm going to do something a little bit novel here. I am going to find the time that it takes for the coin to fall back down. Now you might be asking, why would you do that? Well, if I start at the top of the coin's motion and go down from there, VI is 0. I know that my acceleration is negative 9.80, and I know that since the coin went up 0.25 meters, it's got to come back down 0.25 meters. Now, Pay attention to my DF here. I plugged in a negative 0.25 meters. If I didn't, again, my calculator would choke on this square root because it would be trying to take the square root of a negative number. So, plug everything into my calculator. I find out that it takes 0.23 seconds for the coin to come back down. Now, I know what you're saying. Just a couple minutes ago, I said make sure that you find the total time. Well, you know what? All you got to do is double it. It takes the same amount of time to go up as it did to fall back down. So my final answer is 0.46 seconds. All right, so that's it. It's time to try a few on your own. Let's get to it, and I'll see you in class, and I'll see you online.